Okay, in this video, we will talk about how to find sums of geometric sequences. We've done this process with arithmetic sequences before. So to finish off our study of geometric sequences, we will find sums. So just like arithmetic sequences, we have a formula to do this. With all these things, we need to find values of the sum of m terms is S sub n. A sub 1 is, of course, our first term, just like it's always been. R is the common ratio of your geometric sequence. And n, of course, is the number of terms you're adding. Plug them in and go. So let's take a look at a few. All right, here's one. We're going to find the sum from the first term to the fifth term of the geometric sequence 6 times 2 to the n. So we need to find a sub 1. We need to figure out r. And we need n. So first of all, n, pretty easy, going from the first term to the fifth term. It is quite simply 5. R, recall from the previous videos, is the base of the exponent. So r is quite simply 2. And a sub 1 we will find by plugging in 1 to the sequence. So we get 12. So S sub n equals plug and go. So S sub 5, fifth partial sum of this. And just do the arithmetic. 2 to the fifth is 32. That's kind of, what is that, 31? Negative 31 here. And the negatives kind of take care of each other. So you do your multiplication, and this ends up being negative 372 over negative 1. So the sum of the first 5 terms of this sequence is 372. You could, of course, revert to your calculator, and that's all well and good. But, again, nice to show how the formula works. Let's look at one more example. We're going to find the first 15 terms. The sum of the first 15 terms. So what we're doing is finding sigma from 1 to 15 of a sub n. We know already. We don't know the rule that generates the sequence. We do, however, know the first term. Looking at 3, 9, 27, 81, we know the common ratio is 3 also. 3 times 3 times 3 times 3. And we know that we're finding the sum of 15 terms. So in this case, we can breathe a sigh of relief. We don't actually need to write a rule for a sub n in this case in order to find the sum. So don't bother. I mean, you could if you want to. Of course you can. But I would say don't bother. So the sum of the first 15 terms, plug and go. I'm not even going to bother attempting to do this by hand. Put it into your calculator, and you get some obscenely large number. It should look something like this. Don't forget to divide by 2. So the sum of the first 15 terms of this geometric sequence is this number right here. So 21,523,359. And just in general, geometric sequences tend to get pretty big pretty quickly. So don't be alarmed if you get large numbers like this, especially when you're tripling a number each time and then you're doing that 15 times. And that's how geometric sequences can be summed.